So, hello everyone, myself Aditya Parmar. I am currently SD1 at Social Pilot, which has been acquired by Group.1, and today I am going to show you the implementation process for the task which has been assigned by PayPower Labs as a part of interview process. So, first let's go to the task. So, the task was that we need to clone the Airbnb listing page where it should be pixel to pixel perfect. Front end, back end is optional. So I have read the doc, and let me pinpoint the requirement. First is the visual design should be same, animations, motion and transactions should be perfect, interactions, all the kind of functionalities, keyboard navigation should be proper, and other functionalities are that listing page should be proper photo tour should be there, where you click on photo will be listed of each and every rooms. A light box too, which where each and every photo in a full size view should be visible and it should be easily navigated, and other small fun functionalities are there which I will show in the website. And you can use any kind of tag. For now I use React as a front end, CSS for styling, simple and hosted on a WhatsApp. Do not have included Node.js for now. So the actual and we need to even showcase a architecture diagram where we need to show how a high level system design, basically the back end of whole process of Airbnb works. So for that I have created the architecture diagram. I will show you in that. And the agents which are used for this particular process are mostly Cloud, AWS Kiro and anti-gravity, which I will show how I use them. So first let's start with the uh, website. So this is the website which I have created, pixel to pixel perfect and as a task. So this is how it will look like on, and even have added a loader. Let me show you that. So as soon as you load the website, uh, yeah. So this is the loader. This is a simmer UI or the skeleton UI. I have kept it simple so it can load faster. And once it is loaded, you can see each and every stuff here. So this is the landing page of the Airbnb. Now if you click on this particular photo or any of the photo, you will get a photo tour which will have all the transaction plus that zoom out zoom in effect. Whenever you scroll it up, there will be a sticky header, and the names of the room will stick until that particular photo of that particular room is having the viewpoint. As soon as that viewpoint is over, that title will also be going up. So as soon as this viewpoint is completed, about to complete, it will move up. So that's how the whole photo tour is there. And if you click on this particular photo, then the carousel photo full scale will be started. So this is how it is. You can see. So obviously I have tested, so it was back in particular, but you can start it again. So this is how the photo tools goes. Scroll and done. And now we can other functionalities is that if you like, there will be a small toast notifications above. Then if you reserve, then again the toast notification, show more. Then these are some photos, then some amenities are here there. This basically a sub module which was also there in the original module: calendar, graphics and icons. And this is also the carousel which was there in the original what we saw website. This is the what we call reviews of the platform of the hotels, and this is the other stuff. And this is another functionality of carousel. So in point of functionalities, this is the functionality: one, toast notification, carousels, then like and dislike, which I have done. And there is also a skip to content which will come when you stay on that particular website for a steady long. Then this particular home photo tour, then zoom in zoom out effect. As I mentioned, these are the some certain functionalities which were mentioned in the doc and have been completed, and I have kept it as perfect as it can be. So yeah, over effect is also there properly, which is required wherever it is required. So yeah. And now how I created the prompt, and every information will be submitted to the form. So here is the prompt which I have used. So my flow was simple. First I have collected the information. So let me show you that. So yeah, first I have collected the information, then I have talked to Claude online LLM browser to let me know what are the requirements. what we can do, what we cannot do, what the text text should be and stuff like that. Once I chat with Claude online, then I have created the whole the requirement file, MD file, then copy that MD file, put it here, so that the agent, when we start building, it knows that what will be the MD file, what are the requirement basically. So I have created the requirement MD file. I will go through it, I will reprompt it again and again until it become perfect. Then this is the MD file for the cloud code flow, where the code will go, how it will go, which page should be there, on click of what should be done, what page should be loaded, loader should become, skeleton UI should become, everything is written here. What, and as well as the what will be the flow, like when user click on this, what should happen, what should trigger, how the over effect should work, when the toast should come. Then the folder structure is also been mentioned, how I want the folder structure at a level. So this is how the code flow and structure, folder structure will go. This is also one sub folder structure, how the CSS will be maintained and make it usable as much as we can possible. And this is the testing. Basically I added later on when my website was ready, small as step by step I added the testing also, e2 testing, so that we can test it while development itself. This is style, what the color I want, what will be the code theme, then what will the background, stuff like that. Every small details which Airbnb website should have related to design, I have kept everything here. As you can see it, each and every stuff will be there. And then this is the prompt. I say whatever prompt I use, I have copy pasted it. So basically in prompt I want to say one thing, and I have not like written this prompt by myself. Yeah, what I did is that I write the prompt by asking the chat GPT and Claude, and I ask them to reframe it properly, so I can directly copy paste it and copy paste and give it to Claude code, because it gives us a better understanding of the Claude, better context to the Claude to make it. And the other thing which I did is I added the skills. Basically one is for Airbnb, where the defaults UI of Airbnb, how the Airbnb UI looks, everything was there. Another is the skills, where front end page skill is there, wrapper is there, so that the AI do not create one kind of that purplish pinkish gradient color website every time. It should not. That's why I have added a skill. And this is the testing skill, which for the front end how I need to do testing. And so it has the rules set in it, so that it follows that rule agent. Every rules is been there here, and cloud code setting is there. So basically that's how it is. And what other thing I have done is that I have downloaded the images and stuff, SVG images and stuff, as a folder from the original website which we have. So from this I have downloaded the image and SVGs and stuff like that, stored it, and have served it from front end itself. And another thing which I has that I have even looked at to the source code initially when I was learning what are the requirement. I have looked at the source code, the HTML which we have, how the CSS is written, what is the folder, what might be the folder structure it that followed. Here is the font, because font was not there, we need to download the font from here and use that font. Keeps images, everything I have get it from here. So we can have pixel to pixel perfectness for it. It might not be as perfect, but most relevant it will be a perfect one. So this is how as far as I have done for the website. Let me show the process also, so it will give a better much idea. So I have written everything in the form fill up, where we fill up the form. I have written everything what I have done, how I have done is that. So basically I have written a document, list down the requirement, edit, ask the Claude to give me the prompt, HTML files, HTML file. I have gone to that HTML files, each and every event, clicks and everything, so that we do not miss out any kind of functionalities. Images I have added that. Then have requirement files, MD files, skills which are required, testing skills which are also required. Have it took me around 5 to 6 iterations to make that website. It was bit faster although, but and this how I have created. And one more thing also, that I have added optimization to the website also, like image lazy loading, then React lazy loading, the close splitting is there, then the required custom hooks are there, then use reference hooks are there, use layout hooks are there, where it can picture the pixel much more faster than a normal one, and hosted everything to the WhatsApp. You can look into it and each and every detail. Now let's move it to the HLB, which is more important part and which have I taken a bit of more time to consume, to be honest. And one thing before I start is that it is not like I have taken the reference and inspiration online through chat GPTs, Claude, then blog, articles, YouTube videos, everything as far as I can have this article, then this article. Being frank and honest here, so that I do not get miss out something. I get to learn more, and I can learn that and add that also. So yeah, I have taken the inspiration, but the whole flow is of my how I have idolized the way Airbnb HLB should be. So yeah, to be frank there, and let's just start it. So my HLB breaks into three phases. First phase is a user requesting an authorization where user will request something and authentication will be done. Now the second phase is the backend processing where whatever the user has requested, how it will process, in which manner it will process, how fast it will process, that whole stuff is there. And there is third phase where we will update the required details, DBs, and we will send the confirmation notifications to the required user so that it can also be notified about the process. So that's how the whole HLB is been divided, three phase: request, process, update. Simple. Now let's start with the process. So this is the first phase where user either can be admin or the user. Admin means the hotel manager or the management where hotel details are being updated day to day or required whenever by the user. So let's assume that there is an admin and a user comes and requests something. Then there will be a DNS resolver, basically a top level resolver. For now I use router 50 so that it can know whether the domain which the user is requesting is perfect or not, whether domain exists or not, whether the domain holds a public IP or not. When the domain is resolved connected to the IP, we will hit that particular nearby CDN. And why I have used CDN here, because if let's say user, there are lakhs of millions of user for the Airbnb, and if everybody is requesting something, then the serving of files from the server to the user will get lot more latency. So we have CDNs in between of each and in each and every regions, nearby regions. Mumbai, for India it is Mumbai or Kolkata. Then for outer side of world we have US East, US West, US North, then uh, China, different regions which we have been configured by the respective parties, Cloudflare or AWS Cloud One, so that we can solve the thing much more faster in relevant time. So that CDN will be there. CDN, if something is there which is static, such as HTML file, images, stuff like that, we can directly serve from the CDN itself. We don't need to go for all these long processes. So yeah, that was the first step, second step, third step. Now we will move to the fourth step. It is a load balancer. So basically why we need the load balancer here, because if millions of users are requesting, then we need to balance out each and every request so that each and every request is in process either concurrently or parallelismly, and it has not been missed, and our server do not get loaded. If I have a single server and I have multiple requests on that particular server, then my server will be hang up, which is not also a good way. So for that we normally have kept a load balancer, and this is the ALB, Amazon load balancer. For it, this load balancer decide which server we need to pass the request. Depends on route robbing algorithm, we can use least connection where which server has a least connection we can pass it to there. Along with that, this load and load balancer also provides the firewall protection or even the reverse proxy. Reverse proxy basically means where we do not expose our own original port or the domain to the public, so that it is still secret and no hackers can hack it. If user says 80, then 80 will be resolved here in the load balancer to 3000, where our original backend service been running in the host platform. Optionally, we can use even Nginx also. This is optional. This is not connected, just an optional option which we can use as an alternative. So basically, the round robin firewall, US process, everything will be handled by load balance and API gateway both together. We need API gateway as a appliance for rate limiting, authorization, authentication, then logging codes, then proxies, and to check whether the user is valid or not. And it will forward it to the cognito. That will be a 6-step. Why? Because in third, CDN requested to the load balancer requested to the API gateway, that is the fourth and fifth, and now it will go to the cognito, that is 6. Why? Because uh, rather authenticating user to directly from the DB and backend authentication module, we can directly authorize that user using the Cognito ID at the cloud level itself, so that before transferring that request to the backend server, we can identify whether the user is valid or not. If the user is not valid, we can say directly no from the cloud itself. It will never be redirected to a main backend server, and our backend server will be has loss will be have low request of the user. So that's why Cognito is where we can handle lot of authentication, rate limiting, or the API related stuff, API protection related stuff together using load balancer, API gateway, and Cognito. Once everything is been passed by the user, the seventh step which comes is the microservices. Why microservices? Because we cannot have a every service that's every service in the one single stake, that is a monolithic, because ultimately the load will increase a lot more on that particular service. Let's assume if I have admin service and the booking search service together, then admin is updating as well as there are lakhs of users requesting certain kind of hotel searches, then that single stack will have a lot of has a lot of requests which do not might process sometimes. It will get hang up or stuck up. For that we have divided it into small chunks that resolve services, so that we can distribute our load properly and as per the requirement, as per the request which is required, where it is required, when it has to be response. So the microservices will be there. Once let's say user comes here, pass it to everything, he has requested something. Let's say if it is a admin, then user what does the work of admin is to update the hotel details, images, videos, reviews, etc., to reply the reviews. For that the admin process will be there, admin service will be there, which will handle all the stuff. Although we can break this along the side ahead also using other microservices, but for ease of diagram I have kept one as admin services. Now if let's say admin update some kind of hotel minor details, and we can directly update to hotel DB, although we will have validation stuff like that in the backend, but for just the sake of understanding, we will directly update it into a DB. And if the admin has updated any kind of images, uploaded any kind of photos, videos, then we need a lambda to process that images or photos, because they will be in higher resolution. We need to compress a bit in a way that it fits properly, and and even does not look like that photo image is being flooded out. So for that we will keep a image processing or video processing lambdas in between. We can have multiple lambdas and multiple videos and a queue in between which will process this whole stuff, but for sake I have kept easy for here. Then the lambda process will be done, it will goes to the S3, where we will store each and every stuff. Once it is going to S3, we will update our CDN nearby servers, so that it gets the latest update data. And as soon as something even updates in the DB directly, then also we need to update the CDN so that it gets properly required data. It will be something like this. Yeah, just a second. Yeah, now if CDN is there, and now if let's say user requests a hotel service, basically the listing of hotel, what the hotel will look like, hotel images, room images, hotel reviews, everything will be handled in the hotel service, which will get the data from hotel DB. Although there will be here also the queue systems and other stuff, but for simplicity we have kept it straightforward. Now let's say user want to search something, so for the high priority searches and high frequent searches, we will keep the cache in between, so that we do not have to search each and every time to our Elasticsearch servers or the DBs. So we have kept a search caching in between, we can directly serve from them if it is relevant, or else we will go to the search services which will pass it to the Elasticsearch. Why? Because Elasticsearch provides the full text search, geolocation search, embedding search, so it's very faster at the same time. And even fuzzy search, where user do not know the exact name of the hotel but is a kind of fuzzy, that X Y Z Z Z, then we have to match that properly. For that Elasticsearch provide us that particular services, and it is very easy to use them. Hence we have used Elasticsearch in between there, so our search is faster and it is splitted out from rest of our backend processes, because we need to serve the search faster as compared to any other processes. For that Elasticsearch will be there. Now let's say if a user is there who tries to book something, then there will be a booking service which will start and which will do any kind of other stuff also. But main code is that if a booking service start, a user locked a room, then we choose a room, then we need to lock that particular room so that no other user comes and buy that room. So for that we will use redis lock for temporary, and once the process has been done, we will update the db and remove that particular lock. And booking service will also be related to the payment service. So if a user has to give a payment, obviously, and for that payment we have used stripe. So where we have registered the webhook, it will give us the webhook will trigger and it will give us the data whether the process of payment is been successful or not. If it is, then we will update the db. If not, we will also update the db and notify the user that your payment has been failed. And for that I have kept idempotency cache in between. Why? Because in, let's say that if user network is slow and user try to pay the room book details once, twice and thrice, then it might have booked one single room for multiple times. Transaction can be happen. For to avoid that, we have used idempotency cache in between. So yeah, that's how the whole flow will go for the booking. And booking management service which will show each and every booking done by the user in relevant time directly. And for that we have even kept a caching so that we do not need to go each and every time, because it is not the data which will change frequently. Once I have booked my room, I will check it just that whether it is booked or not. For this we need a caching between, so there our loads on the servers are lesser. Now we have a PubSub architecture, kind of PubSub architecture. There is a producer, there is a consumer, simple, and in between the broker is the Kafka, that is the event bus. We can even not say the PubSub. That's basically the event streaming. Why? Why we need that? Because let's just example say a hotel db has been updated, a hotel data has been updated, our booking data has been updated. So we need to have something where we need to say user that your booking has been done, and we need to say to the hotel owners that sir, your room has been booked successfully. That two different person, the two different events, the two different source has to be know that the process has been completed, and you have to take a look onto it. So for that, what we cannot do, like, okay, first we will know let the hotel knows the stuff, then the user who is booked knows the stuff. It is not a good way. So what is that we will change that. We will update a db. As soon as our db has been updated, there will be a cdc that basically capture data change. It will be identified Cassandra or something, the DB which is kept in between Cassandra or MySQL also. And CDC capture data, what it know, that it will know, okay, my DB has certain data updated which I have to stream as a producer in my event bus. So here, hotel owners, your room is been booked, booking DB, sir, your room is been booked. It will capture by respect to CDC, and it will tell the Kafka, okay, this is the event where the particular room is been booked single. Now you need to tell the user and the owner that your room has been booked. For that we will go to the notification service. Notification service, what it does, it does that it split out the process of notifying, where we have kept SQS queues, where each and every notification will be in the stack or the queue, and as soon as the consumer will be consume something from queue, it will process the queue, take the event, send a notification, take the event, send a notification, take the event, send a notification. So that, because notification is not something we need to show it quickly, except the payment one. It can also find if we have delay of, let's say, 500 milliseconds or 1 second also. So for that we can have a queue where each and every notification has been kept individually. Why? Because we need to notify both of the user, both of the source together, and like we cannot process it just go and send. No, we have to keep a queue where it will process one at a time properly and without any kind of hang-ups. So basically the notification service will become SQS will be there, it will show in the queue. Email service will be trigger, it will take from the queue and send the email. For email I have used SNS and SNS. We can use any other email providers. And for other notification I have used SMS, Twilio for SMS notification, Firebase for app push notification, Apple for iOS notification. we have kept queue so that it is managed properly. Even there will be a dead letter queue here, we can kept it so that the notification which are not been sent, which are failed due to some certain reason, we can retry it again and again. For that we can kept here dead letter queue also here and here also. And let's that's how the first flow is been finished it. And why we need Kafka, that is the reason that if hotel is updated, booking is updated, it will be captured, it will be processed here, event that stream will be processed here Kafka. And whoever is been subscribed to the particular event will know that okay, this particular event has been occurred, I need to process something. So first, as I told, notification service will be know that okay, room is a book, I have to notify now to the user using email or or SMS, sorry, or SMS. So for that hotel, Kafka knows okay, the hotel is being booked, this is a stream, this is the event, no notification, you need to update it now. As soon as Kafka, it is not that once that particular event or stream is been consumed or particular by a particular service, we no one else can consume it. No, it is not like that. Kafka can retain that particular event or stream for a longer period of time, so that anyone can listen to the particular event or the stream. And even if a new consumer is coming to the picture, we not have to keep a particular queue, we do not have to design particular queue and configure all the wirings again. Or it is simple Kafka events queue consumer, and if any new consumer is there, there's a new consumer subscribe to the particular event you want and take the data you want, simple. Hence for that our Kafka, the event bridge, is the centralized hub where we store each and every event, each and every producer data there. And whosoever is been subscribed, whosoever is been listening to a particular event or the stream can take that data and process it accordingly. So let's say hotel booking is done, we have to send a notification. Now we need to update the search index that okay, this particular hotel is been consumed, you need to this particular room is been booked, the hotel is been fully booked and it is a nice hotel, we need to give it a higher rank. Hence search will be updated. There will be we can update the Hadoop cluster where the whole data stuff is there, whole data lake is there. Even I do not know, to be honest, Hadoop a lot, but I have learned just now where we kept the data's joins and then foreign keys together mapped at one place faster to give it a faster response, to map, to look up faster. At the same time we can store the archive consume, basically the replicas and settings of the DB for the backups, monitoring where we can monitor okay, this particular room has been booked, in how much time it was booked, which API will call, what is the latency throughput of the API and everything. So one event, one stream, multiple process can be done, each and multiple process can be done easily at the one time. For that whole process we need Kafka. So that's how the whole Airbnb HLD works, simple and straightforward process. Requested, resolve the DNS, go to the nearest service, if it is image or any hard coded data, any hard coded amount data, serve it directly, or else go to the load balancer, check whether the which service is free, go to the API, check whether the API request is been valid or not, do the reverse proxying, do the rate limiting and stuff. Once it has been done, call the respective services which we have, any of the respective services, then update the DBs, search or any kind of event which we want, or either get it directly from the cache data also. And then update the Kafka, tell the Kafka okay, I have done this. You need to tell each and every event listener who is subscribed to the particular event that you start processing for this particular data. So event will be goes to Kafka, other consumer will consume from it and start other processes. So that's how the whole flow of Airbnb is done here. And yeah, thank you for the your time and respect to. I have submitted the required details on the platform on the link, and do let me know if you require any more details. Thank you.